computer. Then continue. You tell the computer that the data are all category. Category that means 1 equal to what? 2 equal to what? Like that. We have a label. Okay. Then we click the option. We click the correlation. You don't want to name it. It's not roaming. Okay. So we have to put the forward outline. We click the forward outline. When we click the forward outline, the forward outline actually is the stepwise. Same as this time. Stepwise. Because this one is another person create this formula, so they use the different name. But right, they are the same. Forward outline is the stepwise. Same thing. Okay. Forward outline. Okay. After that, again. Then we click up. Okay. We click up. Okay. So when we click okay, there are a lot of tables. There are a lot of tables. So we have 90%. So for multiple logistic analysis and multiple representation analysis, normally our respondent number must be the minimum for each variable is 10%. Respondent. Minimum. So that means if I have 8 variables, you know I have how many variables? 7 independent and 1 dependent. Yes. So altogether 8, isn't it? Yes. So if 8 variables times 10, 80. The minimum must be 80. So I have 90. Then okay, no problem. I can use the multiple this one. So one, the computer will calculate. They will change the value. One is yes. Yes, that means the person have a lung cancer. No lung cancer. Then all the variables are listed here. All the independent variables are listed here. So what we look at? We will look at the block 1. Block 0 you don't need to see. All the table you don't need to see because the table they show the block 0 table before the independent variable enter into the model. So block 1 only you look at block 1. So got 2 steps. Just like just now, isn't it? Got 2 steps, isn't it? If 2 steps, that means we have 2 significant predictors. We have 2 significant predictors. Among the 7, 2 of them are significant. Like this, 2 of them are significant. Okay. So we can see the R square here, isn't it? They show the R square, but the name is different. One is Cox and Snare. This is the name. Okay. So we don't refer to the Cox and Snare because the Cox and Snare is the non-standardized. Non-standardized R square. So we must refer to the negative here. After they make it standardized, the value becomes 0 to 1. 0 to 1. 0 to 1. So we can see the percentage. So what is the dependent variable? Lung cancer, isn't it? 16.8. 16.8% of the lung cancer is because of the first predictor. We don't know the predictor yet. We don't know yet. But 16.8% is because of the first predictor of lung cancer. 26.4% of the lung cancer is because of what? Because of the 2 variable combination of the 2 variables together. The 2 significant variables. Then we will see. Move down. Variable in this one is the most important table. The most important table. So you see, now we can see the first step is what? Living star. The living star. So living star is a predictor, significant predictor of what? Of lung cancer. And for the second step, another variable enter in is the habit, smoking habit, smoking. So 2 variables are the predictors. So, but how we did it? What are the beta value? Their beta value, and so on. So we want to see here significant. So for this one, living star for the first step, one whenever enter is the living star. Living star, this is the chi-square value. What is the chi-square value? So this is the beta value, unstandardized beta value, and this is the odd ratio. Do you know what is odd ratio? Odd ratio. Odd ratio is the percentage. Percentage just like the beta value. For the regression, we use beta value. For the logistics, we refer to this is the standardized beta value. Okay. So living star 0.12 is it significant, isn't it? Is it significant, isn't it?
Yes.
So if it is significant, that means it contributes to how many percent? So we will use 1 minus 0.127 is around 87.3. 87.3. That means it reduced, you know. It reduced 87.3%. Living star, healthy living star will reduce 87.3% of lung cancer. The probability of having lung cancer. Is it okay? Because it's smaller than 1. Smaller than 1, we have to, that means it's reduced. If 1 is 100%, smaller than 1 is reduced. So, if reduce, how many percent? 80 something percent. 87%. And habit. For the second step, the habit enter together, work together. So habit, that means smoking. 1 is smoking. 1, you refer to the 1. Yeah. This table 1. The table here 1. And 1 is what? Habit. 1 is smoker. The person is smoking. So for living star, 1 is healthy. Healthy. That means we will refer to the 1. So here we go back again. It is significant, isn't it? It is significant. So for the smoking person, this one is more than what? 10. 10. That means what? That means 1,000 times, you know, times 100. Times 100 is 1,000 times. Smoking habit will increase 1,000 times of the probability to have the lung cancer. So, or 10 times. 1,000%, 1,000% is 10 times. It will increase 10 times of the probability to have lung cancer. So, for this logistic regression, logistic regression, we will report the standardized beta value. It's the odd ratio value. It's called odd ratio. So you can read any book to understand it. By saying like this, but this is yes, it is how we interpret. You see this one significant, all the significant value. Okay, so the only significant variable will be entered into the model. Is it okay? Any question? No question.